Hello everybody, this is Kunal Mehta from Make Me Scientific and I am the host for this particular video. And in this video I am going to demonstrate the principle of moments, and by using the principle of moments we are going to find the weight of an unknown meter scale. So for example, if we have this small scale and this scale is uniform, right, of uniform thickness. Now exactly at the midpoint its entire weight is going to be concentrated. So if I try to balance this particular scale at exactly the center of gravity where the entire weight is going to be concentrated, this scale does not tip in any of the directions. It stays balanced. Now, the weight of this part produces a clockwise moment, the weight of this part of the scale produces an anti-clockwise moment, and since both the moments are equal, the scale does not tip over. If I shift the pivot point to somewhere over here like this, then the scale is easily going to tip over in clockwise direction due to more moment from this side. This is what I'm exactly going to do in the experiment with the meter rule. Its center of gravity is at 50 centimeter mark and I'm going to balance it or the pivot it at 60 centimeter mark. That means this side, the weight of the scale is going to be larger compared to this side and it is going to produce more moment. And I'm going to add some weights on this side and I'm going to balance both the moments, and by the necessary calculations I'm going to find the weight of the meter rule. So let's not waste any time and go to the experiment.
Here we see the meter scale perfectly balanced at 50 centimeter mark, as 50 centimeter mark is the center of mass or the gravity of the uniform meter scale. Now sliding the thread to 60 centimeter mark, the new pivot point is 60 centimeter. We see that the weight of the scale produces an anti-clockwise moment and the scale turns in anti-clockwise direction. To balance the scale, a clockwise moment has to be generated by placing a mass on the right hand side of the 60 centimeter mark. I am using standard 50 grams fixed mass, and by using trial and error method I will hang the mass at that location where the scale stays balanced. We see the scale to be in balanced position, which means the anti-clockwise moment due to the weight of the scale is equal to the clockwise moment produced by the external mass. Let's see the observations and calculations. Now we shall repeat these steps, but this time we shall add more mass and we will slide the external mass towards the pivot point to balance both the moments. Please understand, moment of force is also known as torque and is equal to the product of the weight and the distance from the pivot. If we increase any one, we will have to decrease the other one such that the product remains the same. Adding 10 grams mass to existing 70 grams mass and sliding it towards the pivot point and finding the final balancing point using the trial and error method. Adding 10 grams to existing 80 grams mass and repeating the above steps. I hope this video was helpful. Thank you for watching the video.